Hello everyone and welcome to another episode of Solving Advent of Code in Rust. And trying to learn Rust in between. I'm Eugene.
Luciano.
Roberto.
Thank you, and thank you for joining and thank you for following along. If you never did Advent of Code, this is basically a set of questions of code challenges, let's say, that's published every year in December in the run-up to Christmas. And there's one challenge every day. We're currently working through last year's one, the 2021. There are 24 challenges. You can find them on adventofcode.com. Now, our code is open source. You can find it on this repo. Thank you, Luciano, for posting the link. The streams are also recorded, so you can see them on our YouTube channel. You could put a link to that as well, Luciano, please.
I don't have it, but you can find it in the About section of this Twitch channel.
Correct. You can find it in the About section of this Twitch, yes. And if you're watching this on YouTube, you can also follow us on Twitch and see these streams live as they happen. So last episode, we solved part 1 of exercise 16. And this episode, we're going to be dealing with part 2. Luciano, I think, said he will drive this one, so I'll let you take it away.
Sure. So thank you very much. Let me share my editor. And probably I need to make it this a little bit bigger. So let's see. First of all, let's do maybe a quick recap of what was the exercise 1. So basically, I'm going to try to describe this. Feel free to tell me if I'm missing something. But the idea is that we have a ticket here. On this ticket, there are a number of different fields, and this is something we don't really know what it means. And we're trying to figure out basically all these labels. The way we're going to figure out all the labels of this ticket is by looking at our input that I'm going to show you. And this input contains a bunch of rules where every rule is a label, and then there are like 2 ranges. And basically that means that if you take a value for this label, it needs to be either in this range or in this other range. And that's true for every single label. Then we have a bunch of tickets, our own ticket and tickets that we found somehow in this hypothetical story that we are living through Advent of Code. And every ticket is basically all the numeric values that we saw in the ticket here. You see that there is question marks and numeric values. For every ticket, we only know the numeric values. So we are trying to figure out, by looking at the rules, we'll need to figure out which tickets are valid, and then we'll try to extrapolate exactly. Imagine that these are columns and they are consistent. We'll need to figure out exactly which field corresponds to which column. Now, I know that I am explaining this very bad, but hopefully it's going to get easier as we go through it. So in the first part, basically, we only needed to validate which tickets were valid or not, which basically meant that we needed to load all the rules as ranges, and then for every single ticket, we needed to see if every given value will be matching all the rules, basically. If there was a value that wouldn't match any rule, then that ticket wasn't valid. And then we needed to return a value that was calculated using the invalid tickets, essentially. And that was part 1. Now, part 2 is a little bit more complicated because it basically says that now we need to try to figure out what column is what. Basically, just by looking at the numbers and the rules, we'll need to be able to extrapolate by exclusion which column represents which field. And I think it's easier if we look at an example here. So for instance, let's assume we have these 3 rules. In reality, we have more, but for simplicity here, there are only 3. The first rule is class. And class can be either a value between 0 and 1 or 4 and 19. Row, again, we have 2 ranges. Seat, we have 2 ranges. And then we have our own ticket, which I think is guaranteed to be valid. and other 3 tickets that are guaranteed to be valid. So, for instance, if we look the first field here, number 3, we need to figure out which one of these 3 rules does it match. And if we look at class, we see that class can be from either 0 or 1, or any value from 4 to 19. So 3 is not included, and that basically tells us that this entire column is not going to be class. But then if we look at the other 2 columns, row and seat, 3 can be fitting here and can also fit here. So this first column at this point, we know that can be either row or seat. We don't know yet which one of the 2. So we can keep looking at this column and see, for instance, 15. And 15 is going to match, again, both row and seat. So still, we don't know exactly which one. And then there is 5. And 5, again, can fit row and seat. So again, we don't really know. So we still have, we know for sure that
15 is not matching the seat, I think.
15, oh, you're right, it's not matching seat. So basically at this point, I think we know everything, right?
Yeah,
because by exclusion, we can say that the first column is row. Then, we need to check the other 2.
The other 2 can't be row.
The other 2 can't be row. So basically 9, we only need to check here and here. So 9 can go here and can go here. So we still don't know which column is this. 1 can go here and can go here. 14 can only go here. So at this point, we know that the first column is row, the second column is class, and by exclusion, the third column is seat. And this is basically what we need to do. Once we... Go ahead.
Quick question. For this exercise, so in the first one, we validated tickets, but in this one, we're going to assume all of them are valid.
No, we have to discard the invalid ones.
Okay, so, okay, fair enough.
Which we can take from part 1. We already have written close enough code that we can recycle.
Yeah.
So once we have the list of all the valid ones plus our own ticket, we can use this algorithm that more or less we simulated now. We need to write it in Rust, which is going to be interesting. But at that point, it's not over. Like once we know all the columns, that like the mapping between columns and fields, we need to do one more thing, which is basically filter only the ones which label starts with departure. Then take the values in our own ticket, so that single ticket that we own, and then multiply all of them, and that will be the result that we need to return. Am I describing it well enough? Feel free to write in the chat if something is not clear. But, I mean, we are going to try to write it in code as well. So we are going to go over this idea again. So the first... Go ahead, Roberto.
So first we have to have an idea of how many columns do we have.
Mm-hmm.
And we can know that from our ticket. So we have to parse again rules, our ticket, and other tickets.
I think I'm going to copy this code here.
Yeah, we can refactor later.
Just make sure to remove the underscore from in front of own ticket.
Now we are going to actually use this own ticket. And then
we have to parse the rules.
We need to parse
the rules.
The rules first, yes. And this is, again, code that we can just copy. Now, at this point, we have all the rules. Then we have our own ticket as a line, right?
Yes.
And then other tickets as all the remaining lines. Okay.
I don't remember in the input if our ticket is 2 lines, one with the...
Actually, let's do a quick print of what we have.
Okay, yeah.
Just to see. Print ln of... What do we have? Actually, you know what? There is dbg, which I only found out recently, and I always forget. And I think in dbg we can just say our own ticket. And then I think input, we need to remove this. And now I think if we run this, we should see exactly what onTicket is. Yeah, we also have the label, and so we need to skip the first line, basically.
We have to split by line, skip the first one, and split the second line by on comma.
Exactly. So there is a little bit of parsing that we need to do. Not a big deal.
And it is the same the similar parsing that we have to do on the other tickets, but well, okay. Let's start with our
own ticket. What do we call it? Values.
Values.
Keep one thing that I want to mention. I think we have this problem in the first exercise as well, because other tickets also starts with the string other tickets in a new line.
Yes, we can copy what we did, I think.
No, what I mean to say is I think the first exercise is accidentally correct. And
like
it's only
this
correct
bit here, right?
Oh, we are skipping the first one. Right, okay, sorry, I forgot we were doing that. I thought we weren't doing it and it was just accidentally working in the first one. Cool.
So basically this will be a vector. Yeah, but no, it's a good suggestion because we can take it from here. So we have a vector of U64, and basically that vector is onTicket dot lines dot skip one. So we want to skip the header, and then basically we can do split.
We need to do next unwrap split.
Unwrap, yeah.
Because it cannot be there. It can be not there, but we know that it is. So.
Split by comma.
With double quotes or single quote?
I think when it's one character, you can just pass a char. And then we can just say...
Map them as integers somehow.
With that parse thing, which we had here. So let's see how we did it. Yeah, this one. So this is ugly, but for now, we are going to keep it this way.
That reminds me of jQuery, all of those chained function calls.
And now he's complaining about...
Why doesn't like this? Use and. Oh, that's interesting. So we can just get the second, right? And
yes,
two.
Is 0 based or 1 based nth?
We don't need. I would think. Good question. Let's see what happens. So now if we do onTicket values, let's see what do we get.
Okay, if it's 0 based, it's going to explode.
It's exploding. So probably it's 0 based. So if we do 1.
Okay.
Let's see if we are luckier now. Yes, we are.
Yeah.
And it's 173 and 59, just as a sanity check. 173 and 59. Cool. So this is our own ticket. Now we also need to get all the other tickets.
Yeah, we have to take the valid ones. So how do we want to do here? We want to cycle over all the tickets, check if they are valid, and skip, so continue on the loop.
We can probably do a filter map. Okay, let's do it. Let's do it in a dummy way, and then we can see if there is an opportunity to simplify. Right?
There is a way to use the code in part 1 to get the list of the... to tell if a ticket is good or not. I mean, sorry if I'm...
I think
we can probably make that into a... what you call it? To a function.
So if we copy all of this, let's start by doing that. Actually, here we were already... Okay, let's do it from scratch, otherwise it will be confusing. And then we copy bits and pieces when we need it.
Yep.
So basically,
the old one was just...
tickets will be what? A vector of vectors of U64, right?
Call it other tickets values, because other ticket is already a variable that we have, and so we keep naming consistent between.
So now we can skip the first one because again that is the header.
We don't have to
Then-
do lines skip because it's a string.
You're right.
Other tickets. Okay. Now
Then-
for row, we have to map. Okay, we have to map filter. You're right, because we have to map this line to a vector of U64, and sometimes we have to not give it back because the ticket is invalid. So
Mhm.
is map and filter.
Now L, it's a line, right? And we need to return some or none, depending if it's matching, if it's valid or not, basically, right? So first thing, let's do ticket. Let ticket, which is going to be the current ticket, and now we can copy all the stuff, right? We can do line.split, blah, 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 collect.
Okay.
And this is going to be a vec of U64. And we do line.split.
Is called
It's
L.
You are right, sorry.
Or
Should we call it line? Maybe it's
I
more.
don't care a lot. Because I mean, you are declaring a variable using the variable the line below and never elsewhere. So even if the name is not very talkative.
Now I'm going to return none just to make it happy.
No semicolon, I think, because.
Oh, yeah. Is it none? Or do you need to pass parentheses? You need to pass parentheses.
Don't ask it to me.
Expected abstract. Oh, yeah. It's expecting a vector.
Yeah, but we can
return some vec something.
Yeah,
Do
but
we
if
not
we
need
want-
to collect the filter map to return a vector?
And then we need to collect. Probably. Okay, now it's happy. We'll fix the suggestion later.
What is suggesting?
I think here that we are not using it. That's the first one. And then filter map can be written more simply using map. I think because we haven't implemented.
Because we are never returning known. Okay.
Yeah.
Mind your own business. We are working.
Okay, so now the logic is that we need to check for every value of the ticket if it's matching any of the rules, which we should have here. So for number, all the stuff, right?
Yeah.
Yep.
And if found is known, at this point the ticket is invalid, and we have to return known.
Mm-hmm.
And we can do an early return, right?
Okay, yes. So what we want to do, actually here we want to return ticket.
Some ticket, yeah.
And then here what we want to do is for number in ticket, because here we don't need to split anymore.
We don't
the
have to
number
parse,
is already parsed.
Yeah.
And then
Contains line 87 at the far right is not n, far right, almost at the end of the line.
Yeah.
contains, that's number.
That is called number, not n. If it's not found in 989,
Then
can we return
return.
known here? Okay, it's not called known and is complaining about number. Okay, we'll see.
Without parentheses, fair enough.
And why complaining for the number up there? Because it's U16.
Because we declare the rules U16, so maybe it's easier if we just make everything U64.
Oh, you can cast there, because that is U64 only because multiplying together 6 numbers, obviously they become some huge stuff. But in the end, you can declare 64. That is part
But
1.
this needs to be as
that is part
U16. Oh, yeah,
that is part 1. We are working on part 2.
Sorry. And I don't think it's gonna like that.
You can probably pass it to number as U16.
Do we need parentheses here?
Oh, guys, it's a casting. We can do it.
Cool.
And now it's complaining about the ticket because
Move the year.
borrowing. Oh my God, no lifetimes. Kill me.
I
Why?
think the loop. No, the loop isn't consuming it.
Because ticket is created in line 85
Yeah.
in the closure.
Maybe we need this.
Okay.
Now why are you? Oh, now it's already a reference. But now can you cast a reference? I don't think so. So maybe we'll need to do something very ugly.
Let's make ticket a vector of U16 and not U64 because line
Found-
85
Wait,
and line 81.
wait.
Okay.
Maybe that will be good enough. No.
Cast it as a reference to U16. As reference to U16. No.
I think we need a reference of number as U16.
My God, it's a fucking number.
Oh, it doesn't like that either.
What the fuck?
I think we need to do this. This is terrible. Okay, I would
man.
be in favor of doing all that stuff. Anyway.
No.
Okay, it works for now, so let's...
This block may be rewritten with the question mark operator. No idea. Replace it with found.
Found question mark. And what does that do?
No, but I don't think that's what we want to do, because that will return every single time either none or some. So I think this suggestion is not understanding what we are trying to do.
Probably.
I don't know what the question mark does, so
I think the question mark will unwrap. So it's like writing here, it's like always doing a return.
okay. No.
Found is none, basically, something like that.
No. We don't want
Or
that.
No. Found.unwrap, something like that. I don't know.
Let's stick with our solution.
Yeah, let's ignore this suggestion for now, and then if anyone has a better way to write this, we'll do it.
Debug the length of other ticket values, just to have an idea of how many of them we collected.
The length of... Say again?
The variable in line 81, other tickets values.
Okay, let's do all of this.
I want to debug all the variable. Can you count?
Let's see if it's working, and then we can do only the length.
Yeah, because
we are getting multiple tickets.
It's a lot of stuff.
Length. Now, if we run this guy, it's where is it?
Where? 190.
There. Okay. Yes.
And how many other tickets are in the input instead? Can you just
we can
go in
the
input file, or
so from 26 to
go.
Well, more than 120 for sure. 263. So it is removing.
It is removing whatever. Cool.
Okay, so now we have
our ticket, the valid tickets, and we have to start to do that kind of exclusion game.
Mm-hmm. So this is just passing the input, right?
Yeah,
okay.
We parse the input up to there. What we can start now is creating a vector wide as the ticket. So I don't know how many columns they are, but we have a variable. We can our ticket value length is the width of the ticket.
Let's do that first. It's basically going to be our ticket values dot length.
And this is the width of our ticket.
Is this not also the length of the rules?
Yeah, probably. Yeah.
Yes, because we have one rule per column. So yes.
Yeah. Okay. Well, in any case, it's the same number. Let's take one of the other. Let's create a vector of this width of sets of rules.
Mm-hmm.
So basically, we start telling to ourselves, every column can be any rule. Then we take the first valid ticket, that is ours, but well, we take all the first valid ticket, and we take the first column, and we see if there is a rule in that set that is not fulfilled, not working with the value, or multiple rules, because probably there can be 2-3 rules that are not matching the value. But we know that the ticket is valid, so we know that the ticket is valid. And we remove from the set all the rules that are not matching with the value. Then we take the second value of the ticket and we check against the set in the second vector of results. I don't know how to call the vector of the columns. And we do this for all the column of the first ticket. Then we move to the second ticket. So those sets start full, but every time we process ticket, they shrink, or they can shrink or remain the same, depending on. At the end of this process, I want to print what we have, because probably we will have a vector of sets. Some set will be of length 1, some other set will be of length 3, and that means that column can be 3 different fields. But then, by exclusion, we can start to get an idea. For example, if a column can be seat and class, and another column can only be seat, obviously we have to move seat from all the other sets, because we know where seat is. And when you have a set of 2 elements and you remove an element, that set becomes a 1 element. At that point, you know that the field, that column can only be that field, and you remove that field from all the other sets. And playing this game until you go down to having a vector of set of 1 element in each set. At that point, you have the mapping between fields and columns. And then we go on.
We do the last step, which at that point should be trivial. So let's write it down, and while I do that, I'm going to try to explain it again so we can see if we are on the same track. So the first thing that we want to do is to have, what are we going to call this? So it's basically like a view of, for every column, all the rules that column is matching. Right, so let's call it guesses for now, because I'm not thinking of any better name. And this one is going to be a vector of sets, hash set, which we'll need to import, of rules, but we probably want to use a reference to rule, right?
Yeah, because the set is mutable. Sorry, but the rule, obviously, we don't want to mute it. We just want to use it. We say that is wide.
So this one, what I'm thinking is, how are we going to initialize it? Because initially we want to have every single rule per every column, right?
Yes.
Loop to every field, because we have the number of fields there.
So what we do is num fields. Right, so we want to do from 0 to num fields, I guess. Dot map, can we do that?
Probably. We don't care about the value. We care about the value. No, we don't care about the value. We just care about doing something. Okay, so here we have to write a closure that is returning a hash set, right?
Yes, so here we have a value that doesn't really matter.
No, so you can put an underline.
And we need to return a hash set
that contains all the rules.
Each and every rule.
Yeah.
How do we do that?
Rules map return a reference to each rule, I presume.
Oh, we can do a collect, I guess.
Maybe.
Of rules. Yeah, you're right. So rules dot keys. Can we get only the keys?
No, it doesn't have keys. So a rule is a struct which has name and ranges.
But we can return
did we have a
reference
list
to the
of
rule.
all the rules? We did, right?
We do, but I think it's a vector of
Which
rules.
is a vector. Okay, then fair enough. So what we need to do...
We can make it a hash set if you want at the very start.
Ether. No, we can do ether, and then we do map, and then for every rule, what we want to do is rule dot. Oh no, it's already a rule. So we just want to return the rule itself, right?
Ah, you want
Yeah,
that?
we want to convert that vector of rules in a hash map of reference to a rule. But I don't know how to do that. That is returning.
Do we need to collect? I think we need to collect.
So hang on, I'm not following.
Okay, now this is I need to make this clean.
No, do this in 2 steps because I'm getting.
Yeah.
No, but well, no, it's fine. Rules, iter. So you are taking the vector, you are creating an hash set from the vector in that way, right or not? What is complaining about?
Oh, we didn't do another collect outside.
Okay.
Now
Just
I
a
suspect that our struct is not hashable, but let's see.
Quick thing, 2 people followed us today and wanted to say thank you to both of them. I hope you're enjoying this. Enjoying to see us struggle with hash sets and maps and collects and everything.
Well, thank you for following.
We also have a suggestion of...
Ooh,
So
let me see if
there's-
I can put it on screen.
You might, I don't know if I can.
Yeah, putting the range in brackets because it's not understanding.
Oh, that could be. So let's start to do that. Range usize, okay.
Better. Why is complaining about that collect?
I think because now our rules is not hashable, but let's see if that's the case. Yeah, rule std hash is not satisfied. Of course, we have a complex struct, and we are not saying how to make it hashable.
Mhm.
So, how do we make it hashable? I'm sure that there is some derive that we can implement here. I'm gonna try my luck with this. Hash.
Fair enough. I like your courage.
Okay, that was bold, but I don't know if it did work. It did change error.
Wow.
So the thread bound EQ is not satisfied. Do we also need to implement EQ? There is another derive that I can never remember. Is it just EQ? Partial EQ, EQ. Let's do this too. Okay, now it's happy. And this one, yeah, I don't think we need to do this. We just need to collect, right?
Mm-hmm.
Because it's an identity function, so we're not mapping anything.
Yeah.
Can you DBG guesses because
yes.
We even need to go .iter on it because it's already a vector.
Oh, we need to implement the bug as well.
nothing else.
The bug. What did you say, Eugen? Sorry.
I was wondering if we need to call iter on rules because it's already a vector. Does it need?
I don't know.
I don't know if it needs any, as in...
Yeah, I think we need to do that.
And it needs to collect it. Oh, so it turns it into a hash set. Okay, gotcha. Sorry. I fell a bit behind. Apologies.
Okay, no, that's fine. Let's see what happens. Right, okay. So it is getting rules.
Okay.
Oh, it seems to be only getting one for each.
No, duration,
Oh, no.
arrival, they are all different.
No, the set is there, and then you have, of course,
and then you have
for
them
every
again.
column. So this is kind of a square at this stage because we have columns and then columns, and we are trying to figure out exactly the match.
Cool. That's good.
Probably there are smarter ways of doing this with less memory allocation using some kind of matrix. But okay, let's make something that works. Then we can think of memory performances and so on.
Mm-hmm.
Yeah.
So now we have our guesses. We have to shrink the guesses down because now they are useless, and we have to start processing.
So the first thing is that this is going to be mutable, right?
The vector itself is not mutable. The hash sets are mutable.
Yeah.
That's going to be an interesting one. I don't know if...
So the vector is always going to stay those 20 probably elements, and they are going to stay like that. But the hash sets are mutable. That is what we want to do. So
yeah, I don't know. Let's see what happens here if we need to put mute or not. Actually, I'm going to remove it because this is a good question. Like this will mutate because we are going to remove rules from every hash set. Basically, until in every hash set we are going to have only one rule. That's the point. At that point, we found all the matches. So this is really mutating. The vector is not mutating, but let's see what Rust tells us.
What Rust think about it.
Okay, so now what we want to do is to iterate over every single column, right?
We want to iterate over the tickets and in the tickets over the columns. And remember to use also our ticket.
Yeah, let's start with our ticket first, maybe.
Does it make sense to include our own ticket as the first element?
Or last is the same. First or last is the same.
Yeah.
Sure.
Well, let's start processing only the other tickets.
I was suggesting we do ours first, just so we get the logic for checking these without being in a loop, which might take longer.
Okay, fine.
Fair enough. So it's just one layer, and then we need to multiply that layer for every other ticket. Good idea.
Exactly.
Okay, so basically what we want to do is for every... At this point, if we have only one ticket, though, we are not reasoning by column. It's going to become by field, right?
Yeah, but we have to go by value of the ticket. So for every enumerate of a field of our values in our ticket, I say enumerate because we need the index to point in the guesses vector.
Yeah.
On ticket values. So this is basically what we want, right?
Can we enumerate that? Is not enumerate how it works? I don't remember. I never remember enumerating Rust.
Why do you want to enumerate? Why do we need the index?
So we
to
can
point
reference
to guesses square bracket that index.
Oh, because that's going to be the column number. Okay,
Yeah.
yes, you're right.
Yeah.
So that's going to be
Column
call.
number.
Let's call it call and val.
Okay.
Isn't? Oh, it needs to be ether. Yeah.
Okay.
Okay. So now we have column and number. So basically, what we want to do is, if
for all the rules in guesses call. No, wait. We have to take guesses call. Guesses or square bracket call. That is a set of rules, right? And we have to check which rules. I don't know if it's a for. Let's think. We have to remove the rules that are not matching the val.
Yes.
How do you filter a set in Rust?
Good question. I don't know if there is a filter. So let's take the set first. Let's do that. So let's do let set is equal to what? Guesses.
Yeah.
Guesses, if I can spell. And we need to get
square bracket call.
Get.
No, get. Okay.
Call. Right? Unwrap. And this is gonna be the hash set, and it's a reference, so we are good.
And we have to remove stuff from there.
And we need to remove. So let's see if set has a filter.
It has a dot remove.
There is a drain filter, which might be interesting. Creates an iterator which uses a closure to determine if a value should be removed. This is probably what we want.
Oh, nice. Thank you.
Okay, let's try that.
That is
and we don't need to assign. Yeah, it's mutating itself, so we don't need to. So probably it's gonna want that this is mute, but let's see.
But well, we can concatenate that to the unwrap later.
So here, what do we have?
The rule. Yeah.
Rule.
And rule as a method to match a value. We added it somewhere. Contains
val.
Yeah, but we have to remove the one that doesn't contain val. So it's not rule contain. The drain filter is removing the one that gives true or false. How it?
Good question.
Let's run it and see what it does.
It's true.
I mean,
It creates an iterator which uses a closure to determine if a value should be removed.
Yeah, but
The function is it's returning a boolean. If the closure returns true, then the value is removed and yielded. If the closure returns false, the value will remain in the list.
Okay. So if the rule contains the value, it returns true and it stays in the set. Otherwise, it go away. So it's not the rules contain.
So we want to keep it.
We want to remove the rules that are not contained in the value.
So it's not. Wait.
Just run it.
Yeah.
If the closure returns true, then the value is removed. Then yes. Okay. Okay.
Now probably.
Now it's gonna explode because this is not mutable, right? So I'm curious if we have to do this as a mutable, and then in turn if we need to do guesses as a mutable. No? Oh, this is probably a reference.
Yeah, and also it's U16.
Can we please make everything U64?
But then you break all the part 1.
It's not that many references, I mean. Or we can just make everything U16 as well.
Yes, and just the result.
If I just do this, right?
Multi-cursor. How to destroy a software.
Exactly, yeah. Did it work?
We'll find out.
I mean, at this point, we can just say year number, right?
Yeah.
That's true.
Was it this?
Yeah.
Okay, and now year is not complaining anymore. Thank you. And drain filter is probably complaining because, unstable. No, this is an unstable feature.
It was too good to be true.
Okay, so
let's do a loop with remove if not contain remove at this point.
I think we need to keep.
Can we remove from an hash that we are iterating over? Probably not.
You can remove from a hash set with a method called remove, but probably not while you're iterating over it.
We are iterating over it, yeah.
Also, I don't know how you tell it to remove, because remove seemed to take a value, which in our case is probably going to be a reference to the rule that you want to remove.
We can do a vector of references to remove and then remove all the references.
And then remove the vector of references, yes.
Yeah, my God, it's ugly.
Well, no, we can do, I have another idea. Like, why don't we iterate over our original array of rules? Actually, to put it another way, right? Now we are starting with this, let's call it a matrix, even though it's not really a matrix, with all the values already populated. We could have done a different approach where we start where initially all the sets are empty, and at the first go, we just fill every set with the valid rules.
Yeah, but then you have to remove them when they become
Then in
invalid.
the next phase, we will start to remove.
But how's that helping? I mean, we're just going to populate it, taking a longer time.
Yeah, probably it makes more sense to start full and going to shrink.
Okay, then in any case, here we can do for rule in rules, right?
Yeah.
What's stopping us from doing that?
Yeah, but the current set doesn't contain all the rules.
But initially, yes, we are doing the first part.
When you are in a set with 3 rules, at one point you can be in a set with 3 rules, and you have to check against those 3 rules, not against all the rules.
Okay.
Because if you check against all the rules, you can find a rule that is not in those 1 tree, that is not matching, and you try to remove a rule that is not in the set, and you get an exception.
Fair enough. My understanding was that at the first pass, we always have all the rules and we remove all the ones that don't match. Only then we will need, otherwise there is probably no clear solution. We will need to have sets where we only have one rule, and then what we do, we just keep going back and remove.
Yeah, we still have to do that.
So my understanding is that if that's the case, we do only one pass to reduce all the sets from all the rules to a subset of all the rules.
Yeah, and that's basically what we're supposed to be doing here. So for each ticket that we have, including our own, we go starting from a full set of all rules for all columns,
fields,
and we see if any of the values that we've reached don't match a rule, we remove the rule from the set.
Exactly. So that's why here I was saying that in this specific case, since this is still step one, we can iterate over all the rules.
Yeah. For step one, we can iterate over all the rules. It's true. But that with just the second ticket can be that some rules are not in the stuff anymore. If we want to use this code with a for outside to make it generic for the other tickets.
Right. Okay. I see your point, because then we'll go.
But there is no way to use that. The drain rules is unstable. The drain filter is unstable, right?
So if we do for rule in set, let's see if we can do that remove.
Question.
If not rule contains value.
Question.
Go ahead, sorry.
Drain filter is unstable, right?
Yes.
There isn't a way to use those unstable features? No.
We can search. I never did.
So just to say, okay, now we solve it with an unstable function, then we will refactor.
Fair enough. Let's figure it out. That's probably easier than doing what we are doing. So what was the use of unstable hash drain filter? And there is an issue here, which I am sharing my entire screen. Yes, so I can put this one here. Are you seeing it?
Yes.
Yeah.
You might need to zoom in a bit though, because thank you.
So drain filter, how do you use an unstable feature? Rust use unstable feature. Let's use Google.
Sorry, viewers. We are so noob.
Feature this way. So if I'm gonna put it on top, but I have no idea if that makes sense. And the name of the feature is called there hash drain filter.
So you declare, I want to use this.
Is it happy? Feature might not be used on the stable release channel, so we need to switch to the what nightly compiler. Okay, let's not use an unstable feature. Sorry, stupid question from me.
Let's just do a vector of references.
Yeah. Back.
I think we might put something in our cargo file to say that we want to use nightly.
Oh, so it'll be for per project. Oh, somebody new followed us. Thank you very much.
Let's see.
Hakaro or Hakaro, I'm not sure how to pronounce that. Apologies if I butchered it.
About Elixir.
Luciano, I think you've either read about it or used it at some point, right?
I only know that it's a very well-documented language if you want to understand functional programming. But then I didn't spend enough time using it to tell you that.
When I was in Amazon Redshift, we were looking at it to replace our Ruby on Rails application for internal DevOps dashboards. But in the end, it was 2016, and it was not mature enough to go in production in Amazon. And also, there was only one guy in all, basically, AWS able to write it. So, no, I'm joking. There was only one guy in our team able to write it. So, I don't see a lot of traction on Elixir, to be honest. I liked it. I wrote something at the time on it. I was playing with it, but yeah, to be honest, I don't see a future for it right now. And functional programming in general is very hard because the entry level, so the bar to enter the languages is a little bit higher than a normal language. Like with Rust, the bar is higher. At least Rust is not functional.
I don't know if that worked or if just I killed the Rust Analyzer.
Rust Analyzer is suffering.
So what I found is basically that here it's saying that you can specify in the cargo toml features that you want to enable.
Mm-hmm. But
and then you also need to say unstable. Maybe.
Let's go back to the idea of Eugen of having a vector references and then remove them from the hash set because it's
it's probably too painful to do this. Let's remove it. We'll check that in another.
I'm not sure if it's painful, but it'll probably take longer.
Mm-hmm.
So it's probably something we need to figure out, but figure it out when we're not fixing something else.
The Eugen idea was Eugen.
Rust Analyzer now is alive.
The idea was to just keep a vector of references to rules, which are going to be the rules to remove, essentially.
So we can do let mut vector of references to rule.
It doesn't even need to be mutable. It just needs to be a vector of rules, which we delete once the loop is finished.
Yeah, but if you have to add the remove from the vector must be mutable, I think.
But the set, so set is the name of the variable, which is currently the entire list of sets which are valid. So that's already mutable. Yeah. This is just a list of references to the rules that must be removed from the other one.
Mm-hmm.
So for rule and set, if not rule contains value, add it to another vector, basically.
One thing that I want to do first, just to make sure that we can or cannot do this, I'm going to try to do
set remove.
Set.remove. Then if it doesn't work, I get your idea of collecting all the values we need to remove and we remove them in another step.
Yeah, exactly.
Rule. Right?
It might work dynamically.
Keep that line commented later.
Now it doesn't like what? That cannot borrow set as mutable as it's behind a reference.
Oh yeah, because the rules are referenced.
Probably we need here an iter mut into iter.
Maybe.
If we do iter, can we do as mut? No, mutable.
Okay, this is black magic.
It says cannot borrow set as
can it be
mutable.
that on line 99 the hash set is not created as mutable, or that it doesn't matter?
Let's try to put this one as mutable as well, just in case. Because for now it's going to tell us it's not going to need to be mutable. Let's see if that changes later on.
Yeah, but right now that's still underlined in red, which means it probably still can't borrow.
And in 106, what is the problem? Still is borrowed as mutable?
It's saying cannot borrow set as mutable. Okay, let's do then what Eugen suggested. Because this might be a way to protect us from mutating while iterating.
Yeah.
So
now, that might also not work, but it's worth a shot.
To remove, well, let's call it rules to remove. And what we want to do is set
Vector.
filter.
It's an empty vector at the beginning.
Yeah, but I think he wants to just keep. It makes sense. You can filter over the set, but it needs to be iter first, no?
Yes. Is an iter. It will go above all the values, yes, and then filter, and where basically here we get a rule.
Mm-hmm.
And
Three references, oh my god.
Jesus.
That is always not contained.
That's it? Not contains, yes.
Not contains, yes.
Okay.
Cool.
Now,
You have to collect. You have to collect at the end of
rule.
that line.
Yes, you're right.
I don't know if you need to. Do you need to collect if you're going to iterate over?
Yeah,
it?
because filter is lazy.
Yeah, but when you iterate, isn't that going to trigger it, or is it not?
Wait
Cool
a
if it
second.
did.
Why it doesn't like it? Oh, because it doesn't know what to collect. So we want to collect what? A vec of rules?
Of references to rules.
References. Rule, not rules.
Rules, sorry.
Okay, now what's your problem? Yeah, that we have that double thingy.
Triple.
Oh,
This is gonna be a long one, isn't it?
More rules for more references for everybody.
filter map. And then if
Declare the rules to remove as a vector of reference to references to a rule.
okay.
Go back to the filter. Now, other reference are in the type there. Okay. Complain again? It was fine. Yay!
It's fine.
Yeah, somebody. Sorry, we got a few comments. Somebody agrees with me. They say don't collect, just use the iterator, so that probably works.
Okay.
Also, somebody said reference of reference of reference, which is exactly what we're doing.
Oh, fair enough. We don't need to collect because we are doing a for straight away. Yeah, good
Exactly.
point. Good point. Thank you very much. And now basically for rule in rule to remove, what we want to do is set remove rule.
And now
And now let's see what's the problem.
the same as before. Yay!
Jeepers.
So what is this shared reference?
Try to do this, Luciano. Copy in line 103 guesses.get.unwrap.
No, I think the problem is here.
Yeah,
I
instead
think
of
we need to get mute.
Mute.
Is that good enough now?
It's less happy now.
Cannot borrow set as mutable because it's also borrowed as unmutable. So mutable borrow occurs where we did it, and immutable borrow is 106. 106?
Oh, when we loop through it.
when we do in line 104, when we call set at that point, that is a borrowing of the. So we have to not do set, but reference to set iter on line 104.
104 here.
Yeah, there we are borrowing as immutable, it say.
Okay, so put an ampersand in front of set, I think is what.
No, I think we need to do borrow mute.
Oh, why that? No.
Yeah, because no, I don't know.
The value are dropped. Why?
We are getting into the beauty of Rust.
The clone.
Clone, slap clone everywhere.
We're already slapping on wrap everywhere, I think.
Okay, let's reason for a second, based on what we understand about Rust. So
Not
let's remove this one for a second. I just want to see the error. So basically it's saying that
if you over on the error.
no, let me restore this one. Okay, so the problem is that set. What is set? Set is the entire hash set.
It's a reference
that
to the
we are
hash set.
getting. Cool. And so here we definitely need to do get mut because we want to mutate that set. And this is fine. Now here it's saying that we are also borrowing the same set.
If you over on line 107, it tells. Let's read it together. Over the mouse. It says that in line 104, immutable borrowing occurs here.
And we
In
also
then
got
in 106,
column 31, which is this one, yes.
we also got a suggestion to iter mute here instead of just iter, which might work. So
Didn't we do that before?
ooh,
Wait.
there is no iter mute.
maybe not on sets.
Do we need to make... No, guesses is mutable. So why don't we have... Do we need to do iter and then as mute? Borrow mute? Is this the suggestion?
Well,
Which I
the
think is what...
Try. Still unhappy. I should wear my glasses instead of leaning into the screen, sorry.
Now the value that we want to put in the vector in the implementation are dropped out of the... Oh my God. It must not be that hard. It's a set. I want to remove stuff from the set based on a rule.
Okay, let's... Now, it's a set of references, though. Which is actually fine, but...
It's a set of references just because I don't want to copy the rule, cloning the rule forever, because it makes no sense to clone the rule.
Question, what happens if with the reference there? Sorry, I mean this.
That...
It's probably the same. I think it's implicit that the reference. Yeah, it's the same error. So this is doing implicitly doing the same.
Okay, guesses get mutable.
Oh, you know what? I think if we collect, we are going to be able to avoid this problem. Because the problem is that in this line, we are still retaining the borrow because we have an iterator that gets created.
Okay. So
let's redo that collect. So this is going to be a vec of what?
The references to rule. One or two ends we have to see.
You're right. Yeah. We need to do 2% for fun. Now, is it retaining the... Now it's probably a different error. Immutable borrow... No, it's the same. Why? My understanding is that we are not going to use the set anymore in this line.
We have to use the set in line 107. Can we clone line 103?
We can literally go set.clones.iter.filter.
In line 103, can we...
Okay, I was trying something, just don't mind me. I'm gonna revert and then listen to you. Sorry.
So you can get set.cloned.iter.
Oh, one is that one. We can try that one. One, yeah.
The problem is that we need to do the rule clonable.
Is it? Temporary value. Oh, that might be because no.
So now it's working.
Now it's not
it's unhappy.
What is
But I don't
complaining
see.
about? Temporary
temporary
value.
value drop. Is there an example? Hello and hello.clone. Okay.
Okay, go back.
Clone.
Claude set.
Now it's gonna complain that on. Okay, so now if we use clone set, are you gonna be happy?
Probably not.
Hey, what is the difference?
Oh, it is happy.
Hey, what the fuck is the difference? Oh, better not ask.
Okay, I am
Okay.
surprised that it's not asking us to make this
Because the
rule.
hash set is clonable, and they are referenced to rules, so we are not copying the rule memory. We are copying the hash set memory, and the hash set is clonable.
That's why, yeah. If this one wasn't a reference,
okay,
rule needed to be clonable as well. That's
run
why.
it. I don't expect to see a lot of rules going away after one step with our ticket.
Can we get just the lengths of the different rules sets? So we don't have to look through like a massive output.
Yeah, the length of the hash sets. Do guesses.map and get the len. And convert the hash set that you have there to hash.len. And is smart enough or
no?
So we have to assign it to a variable.
Guesses is what? It's a vector.
Yeah, guesses was not a vector of sets. And the sets have a len or not?
Right.
They have a size. Is called size or len name?
That's a good question.
Yes. Sizes.
No, it's called len, and it returns a usize.
So it's a vector of usize. That is guesses dot title dot map dot stochastic. Yeah, sorry.
You're right.
Dot collect.
Oh my god. No.
He was also happy there for some reason. Anyway.
Okay.
Cool.
Okay, what do we have out of here?
2020.
So, applying our ticket, nothing is changing. We have to
change our ticket.
So we know that it's useless to apply our ticket.
Let's change our ticket to see it actually work.
Yeah, let's use.
Let's find a value. Let's find a value that is not in a rule. Show me the rules in the input. Okay. Oh, up. Okay. For example, if we put a 1 in a field, if we change 173 with 1, let's remember 173. I think
we can revert.
A lot of them will stay
0.
Okay. 0 because there are no rules that match 1. Fine.
Perfect. So it
let's
works.
Let's try to go input and find a value that match only one rule.
Wait, I want to do this. Now we should treat zeros, right? Just to validate this theory.
Yeah.
So 0, 0, 0. Perfect. Okay.
I was saying scroll 25 is a good number. 25 probably is matching only one rule. Okay, so put 25 as the first. Put 25 as the first element.
And you expect to see 1 for the first.
I expect to see if I'm not wrong, because it was a very fast look at it. Yeah,
1.
So
correct. Cool.
It seems to be working. So now we know that we can.
Now we revert this guy, and then we need to extend this logic to every single ticket.
Yeah, but it's enough to put a loop in outside around it, and we are done.
It
Also, we
only
know
took us an
that
hour.
we can avoid to run it on our ticket because we know that is not changing anything.
Fair enough.
Yeah. Well, yeah, I guess.
Yeah,
Or we can
sorry.
just add our ticket to other ticket values
Yeah,
and then iterate
we
over
can,
it and
yeah,
just
okay.
do the logic.
True.
Basically wrap this stuff in a loop.
True. Yeah.
Yeah, a loop that goes for ticket in other tickets, right?
Yeah.
Yeah. And our ticket.
Other tickets values, it was the variable.
Our ticket values, yeah.
Yeah, that was the
And now, rather than using
line
ticket
one of
ticket
values.
value, we use ticket, right?
Yes.
He's complaining about what? Okay, no, nothing. It's just...
Nothing.
Now this is doing all of them except for ours.
Yeah,
Actually,
but,
let's run it and see the
let's
outputs.
run it and see the length. So I hope that there will be at least one field with. Okay, there is a one.
So this
there.
one has 1.
There's one that has 20 though.
Yeah, but now there is the trick.
Yeah, I think now basically if we take this value and we remove it from every other, there will be probably one with 2, this guy.
Yeah, that will become 1.
And
then you take that one and you apply
3,
that.
4, 5. Yeah, okay, so it's doable.
And also, remember that we care only about the departures. If a field remain ambiguous between seat and class, fine. The important is that the fields that start with departures are not ambiguous. Instead of printing the numbers in that debug, can you print the names?
The name.
Yes,
the later.
You can do that. Because, no, you can't. Because it's not that line. You have to iterate over it.
Yeah. Nothing. Don't. Yeah, it is a map, S map, and take the name. Fine. Let's not waste time in this.
It's fine.
Should be just or and then or.name.
Name.
We need to remove that underscore for reasons. Yeah. And this is going to be not a vector of usides.
Strings.
But what, a vector of strings?
We can join them. Can we not join them with a comma or something?
Wait.
We can do what we want.
A vector of string.
Or that.
Right? Name is what? An str or a string?
I think it's a... let me check, because I have the code.
Which does not implement copy.
Oh, reference.
So it's a reference to a string. And now collect is...
Seriously? Okay.
So
now we should see all the rules. Okay. So there should be one guy that has only 1.
It was there before. Okay, right. So we know that field is root. So all the other fields...
if we got the one that has 2, there needs to be route between these two.
It can be if we're lucky.
And if we're not, this doesn't work.
So here there is route where there are 3.
Go down to 2. It's the one with 2. Disappeared.
There is route. So at that point we know seat. And we can remove seat from that one that has 3. And that's what we also
seat and root from that
one. And we know that this is
that will become type. Then you have to remove root, seat, and type from all the others, and so on, cascading.
Yep. There's 2 ways of doing this. One is correct and one is not.
Sorry, why?
No, it's fine. I'll keep it to myself. I'll tell you later.
So now, how do we do this logic? We need to find all the sets that contain only one rule, iterate over all the others.
We could order. So, what are the sets right now? Is it a vector?
No, if we change the order of the vector, we lose the reference to the column.
Yeah. You're right. Okay, never mind. I was thinking we could run over them in, what you call it, in order of length.
So we have to take all the rules in our guesses that are of length 1 and remove that one from all the other sets, not from his own, because if you remove it from his own, it becomes of length 0 and is dead. And you have to remove it from all the others.
We can probably just do a while over the vector and try to find rules with a length of 1.
Yes, and then loop over the vector again to remove from the other positions.
Mm-hmm.
And you have to do this, and you have to do this until or all the rules are of length 1. That means that we have the mapping, or at least all the ones that have departures in the name are of length 1. Because we just care about departures, we don't care about the others.
Yeah, that's true. It doesn't seem like the way we've done this so far, it doesn't sound very efficient. So I think after we finish it, we can probably do a whole episode on making this nice. Or fast,
but
at least.
that drain set is unstable. It was so handy, that function.
So am I explaining this correctly here? At this point, we expect that there will be at least one set with only one column. We can remove that column from all the other sets. At that point, we expect that there will be other sets with only one rule. Let's say column. So we keep removing that column from all the other sets. We keep going until all the rules, all the sets are of length 1, or at least the ones with departure in the name.
Mm-hmm. Correct.
Yeah. To do this, we can work on that guesses sizes vector of string, or we go on with the rules. Because now we don't have to check numbers against anything anymore. So the concept of rule now is gone. Because we were using rules because we were calling contains, and we had to have contains. And now...
Yeah.
For simplicity, for mental simplicity for us, I mean. Because continuing
so
with the triple references of rules is a little bit mind-blowing for me.
I don't think it matters that much. I think let's try to keep
like
rules,
you want,
and then if it gets too complicated, we'll switch to something like this.
Okay, so
cool.
Let's choose just one pass. So let's search for a rule for a guess with length 1. There is a handy way to get it, like find.
I think yes. What I was thinking is let me try to describe my idea first, and then if it's too complicated, we'll break it down. So I was thinking we can have a loop that is endless. So we just say loop, right? And eventually we'll break.
Mm-hmm.
Now, here we have a set of the columns or the rules, whatever we want, that we are sure we identified.
Mm-hmm.
Then basically we keep growing that set until we fill it completely, or until we see all the departures in it, depending which rule do we want to apply. And in this loop, basically what we do, we keep removing that rule in every place where we have more than one element. Make sense? So here we will have a set of all the rules that we are 100% sure we found. So initially we need to do a find to initialize it, and there will be at least one. Then this loop, we keep going through all the other sets, and we remove every place where we have that rule, but there are more than one element.
Yeah, okay, I got it. Okay.
And then every time we remove something, we check, is it 1 now? If it is 1, then we found another match, and we increase the original set.
Mm-hmm.
Okay, so now we have to create let mute.
Exactly, let mute sure columns, something like that. Right?
Now, are we sure we want this to be a set and not a vector? Because we can... Oh no, because no, never mind.
In the end, we know that they are unique, so it's
Yeah.
just for a little bit of memory efficiency, probably.
Yeah.
I don't know if it's more efficient a set or a list or vector. Performance-wise, probably a vector is faster, but we are not looking at performances now.
Yet.
Normally, that is what stuff that we do in a pull request in the episode after. References to rule, no?
Right?
Triple. Quadruple
Yeah.
Mm-hmm.
I don't know many or not at this point.
Okay.
And
so
here we have to put at least one rule, that is the one with a find. We can use a find.
let's see if we can use a find. So basically, we want to iterate in guesses dot either dot find,
Find, yes.
and the predicate is gonna be, what do we have here? Column
We have a rule
rules,
there.
and we want to find one that rules dot len equal one.
One. Yeah.
Mm-hmm.
Unwrap? No. Do we have
And
to
we'll
unwrap?
probably need to unwrap. So let's do an expect. There is gonna be only one.
And we have to add this to sure columns.
And basically, we need to do, let's say, let's start rule now, or start the column,
Yeah.
and then we do sure column dot add or append. What is it?
Push, add, append. I don't
Push.
remember. No, I
Insert.
haven't.
Insert.
We said everything except insert.
Why this is an
Why
hash set?
it is an hash set? I want one.
Oh yeah, because here we are finding a list of hashes.
No, it's not finding one.
Our
Yeah.
guess is a.
It's a vector of hash sets of rules. No?
So we
yes,
will need to
we
get.
have a hash set with one element, and we have to take the one element out of the hash. We know that there is only one element in this hash. How do we take it out? Iter next, iter first.
Let's do first.
First.
Is there a first? No, there is.
There is no first.
There was first. Because I used it somewhere. Isn't it an exercise one?
But well, fine. That is something.
Didn't work.
Oh no, I was using next. Never mind.
I did remember that as well, but probably we are wrong.
Or is on top of another type of object. Remember, is a set that don't have an order, so I don't know if first makes sense for a set.
Correct.
First makes sense for a vector. But well, let's go on. Now you said for all the column longer than one element.
Mm-hmm. So basically what we want to do is for guess in guesses. Well, let's call it column.
Yeah.
Yeah, column. Columns, because it's plural. In guesses. If the length of columns is greater than 1,
columns.len is bigger than 1. What we want to do is for every element in sure columns, we remove all of them.
Yeah, those are two hash sets. There are intersections. What is this? This is a difference. This is not an intersection. This is a difference between hash sets.
Let's see if columns has some
method.
Remove.
Remove is for an element.
There is difference. But what is going to do? Is it going to return a new?
Or modify place? I don't know.
This is the value representing the difference. So it creates an iterator. So it's not going to change. Mm-hmm. It's just a way to iterate over the difference.
Cool.
No, so we have to remove. No.
Okay, let's do a dummy for now. For val in. I'm running out of names.
Ensure columns. Ensure columns.
And let's call it call ensure columns. Columns
Dot remove.
remove call.
Call. What happens if call is not in columns? It can be.
Maybe it doesn't do anything. I don't think this one can fail. It just returns true or false, I think.
Okay, perfect.
But why is it unhappy though?
Because columns is not mutable, probably.
Guesses is moved due to its implicit call to into either. Where is into either?
When you go for column in it.
Either. Okay, then what's the next problem? Why are you yellow here? Thank you. Yes, that's what I want. Then sure columns again, either.
And then columns must be mutable.
Okay, columns. Where do we get columns? Here. So either borrow mute. Now why not?
This might be because we're trying to modify things that we're looping through. Again, same as we had the issue before.
No, we are not. We are not looping over columns.
Yeah.
No, we are looping on guesses, not on columns.
The first, so line 130 for columns in guesses.
Yeah, but we are looping on top of guesses, not on top of columns.
Yeah. Ah, okay, yeah, you're right.
We are looping on top of guesses, but we are not changing guesses. Guesses is of this length from the start to the end. We are not touching it. And columns is an hash set in guesses, and we want to change it in place.
Yeah. I think we need to learn a bit more about this reference and borrow.
Exactly, yeah.
Or at least I feel like I need way more.
For sure. Right now, my approach is make the editor happy.
Fair enough. I'm happy.
So, how can we remove a call from columns if we can't? How do we declare that columns is mutable?
For mute columns?
Is there a way to do a mutable for?
I think so. Like, I don't know if by default. Try it.
Ooh.
It does not need to be mutable.
Wait, because maybe we still have this.
And what's the issue now? It's behind an ampersand reference. Can we start?
What if we do this?
That's what I was thinking as well. Type pool.
This. Cannot borrow as is behind a reference. Yeah, I think because columns is already, so guesses is already references to hash sets. So here I think we need to do borrow mute, and then
you can remove the mute because it's already mutable, right?
I think there is a difference within mute and mutable references.
Yeah.
I think mute is just for values. Then when you have references, you can have mutable references or immutable references.
Yeah, fair enough.
And you can have mutable references as value, which means that you have a reference that you can point to different things over time.
What we did in the previous loop, because this is what we did, similar to what we did in the previous loop. We were having set and we were removing from that set. How we
made a list of rows to remove a vector.
Get mut and wrap.
And we used clone also.
Oh yeah. Fun.
Fuck.
Yeah. We're very good at this. do we just replicate that logic? Or do we want to do our homework and do this proper next week?
Do a numeric loop.
Like?
In 130, we are doing, instead of doing 4 columns, do 4i from 0 to the length of guesses.
Okay.
Yes.
To the length of guesses. So should dot, I think, after the 0. Yeah. Now, inside this one, at this point, columns, you can do let mut columns equal to guesses get mut.
Mm-hmm.
Get mut of I. I don't know if you have to unwrap or not. Yeah, because it's an option. So at this point, column, you don't have to declare mut, is already a mutable hash set.
Yeah, because again, it's the reference here that is mutable.
Okay.
And that's fine.
Do we need all that at line 134?
I don't know. Try to remove it and see what it think about it.
It likes that.
It's ugly. This is ugly, but it's working.
Yeah.
Fine. Like I said, I make the editor happy. That's my job. So, when do we have to break?
Wait, this is not finished yet, because we might have found, every time we remove, we might have found a new sure column, right?
So find it now, I suppose.
So I think after this for, if columns.len is 1, at this point it means that we found another sure column, right?
Yeah.
So what we want to do is
sure columns insert.
Sure columns dot insert the value, which is going to be columns dot either dot next dot unwrap.
The only value in that set.
Okay. Now, when do we break is the question.
Let's do it simply where sure columns is the same as the length of rules.
Yeah, let's try.
You know what we can do?
Let's try. If sure columns len is equal to guesses len, break.
Yes. Would we do that where? At the end of the for?
Yeah. We can do a while. We can make it a while, but we can do that like now, like this now.
Len double equal.
Because I'm JavaScript.
Okay.
Break.
Yeah. And now
I don't know if
this.
I don't know if this will work, but let's try.
So now, if we run this code, we should see all the values, all the sets in the guesses with just one label, right?
If there
is no ambiguity, yes. If there is ambiguity, remember
it's gonna run forever. No, it didn't run forever.
Oh, nice.
Okay.
Cool, I found them.
Cool. This is our mapping.
Wonderful.
So we're getting very close. Okay, let's try to finish it, and even if it's ugly, we'll revisit next time. But at least,
ugly is being very,
very kind.
Very kind with this code. But okay, cool. Now we have. Now we can make the. Oh my god. Okay.
Oh, we need to find them.
Now we can go. Now we can go to that guesses sizes string.
Yes, and we need to find all the ones with departure.
And we have to find all the indexes, numeric indexes of the strings that start with departure. Because go back to the debug from before. Because I don't.
Or I'm gonna run it again.
There is a list of lists, a vector of strings. Yeah. Now we want only one string.
We can flatten this.
Yeah, can we flatten this?
And at this point, we have all the indices by position, right?
Yeah.
Yep.
How do
Yeah,
we
let's-
I
flatten?
think we can flatten flat map. Oh yeah, we can do flat map here, I think. Is that gonna work?
Now it's a vector of string, not a vector of strings in the
Yeah,
end.
you need to update the type declaration.
No, it's not happy.
What does it want?
Wait, let me see what flat map does.
This is map now.
So maybe
This is map.
if we do flat map, what is the definition?
It's giving you all the at this point flat map. It must give you just rules, not a set of rules. Because probably it's being a Nash set and not a vector of vectors. Is not working flat map.
Well, technically, at this point, we can just map over.
Exactly, we can map again.
We
Right,
don't
and
even
just
need to
take
map.
the
We can
first-
just get the
No,
first
what I'm
element.
saying
And
is
that's it.
that exactly. We flatten ourselves, basically.
Yeah.
Yep. And to be honest, you can probably do this in a single step. Maybe.
No,
Anyway,
let's
it
do
doesn't
two
matter.
steps.
2-step is fine. Yeah.
So
You have
here,
X,
our value is what?
A rule must be no.
No,
Is a set.
it's a hash set of rules.
So we want the first element of the hash set.
Yeah.
So again, we do the usual
No,
map.
Iter,
don't
next,
get-
wrap.
You can no, you can just get the first element because it's a hash set, right?
But
But get
But
they
doesn't
don't
have a
get.
position.
They don't have a get.
they don't.
Unless you can do get 0 and then unwrap, but it's the
I
same.
don't think.
There is a get. No.
Type annotations needed. Why?
Reference to a rule. Fine. No, sorry. It's not reference to a rule. It's reference to a Nash set of references to. Oh my God. No. Is sorry. I'm wrong. Name collect.
Oh yeah, I think this double map doesn't make sense.
Okay.
So here, after we collect, I think is where we can literally just.
So rather than collect, we do next and we do unwrap.
Yeah.
Okay.
That should be it. Let's see.
Run and debug it because. Okay.
Yes, cool. So now we only need to find all the ones that start with departure and keep the indices.
We can do a for with an enumerate again.
And we don't lose the index.
Initialize an accumulator to 1. We have to multiply all the numbers together, right?
Mm-hmm.
Yep.
Okay, our result, let me mute result equal 1.
And then we do for it's gonna be what?
Index, comma, guess name. In guesses names, enumerate. Do we have to do enumerate or iter enumerate? I fuck them, I remember. Okay, now, if the name starts with departure, how do we do that? Starts with? No.
Yes, lovely.
Departure. Yeah. Our result is star equal. Our
We
ticket
multiply by own ticket values. So get I unwrap. Boom.
Now we will return that result that must be U64, but borrowed move. When we debug in 152.
Wait.
Yeah, you can debug probably requires a reference?
Oh, the bug is probably consuming it. Okay.
Might be, yeah.
Yeah.
So we don't need to debug anymore, and we don't need to debug in reasons. Okay, this is super ugly, but hopefully it's gonna work. Boom, works.
Yeah.
What was complaining about? There was a.
I think that the bug consumes the entire value.
No,
so
no.
you can.
When you run the test, there was something in the output.
Oh, that underscore, I think. No, borrow mute. We are not using borrow mute anymore.
Okay.
We should also rename the rule from underscore name to name, and overall we should fix the whole thing.
No, I think the multi-cursor was dangerous there.
Mm-hmm.
Name. Well, here is not. Oh no, here you can just say name, and then we are using it at the end. I think there, name. Cool.
Run both tests. Okay.
Still working.
Okay.
My suggestion, since it's already late and we have been streaming for like what, almost 2 hours, is to commit all the stuff, close, and then next time we'll try to make it a little bit nicer.
They were suggesting for mute columns in reference mute guesses. Okay, we will try that.
Now, definitely.
Now it's working somehow. It was hard.
Yeah. By the way, thank you for all the suggestions. You're super
Yeah,
helpful.
and also we have a loop with a break that can be a while.
Yeah.
Kind of a little bit more.
Okay, cool.
Better.
Eugen, I'll leave it to you to do the closing beat.
Oh no, I need to read. All right, cool. So we'll stop it here. So we're leaving it here for now. Obviously, you can find the recording on YouTube a bit later. The link for the YouTube channel is on the Twitch About section. If you're watching this on YouTube, we live stream this on Twitch every Monday, 5 p.m. UTC, which is currently 6 p.m. in Ireland. So check for the Twitch link in the YouTube description and follow so you can be notified when we put out new content. Feel free to leave us comments or open PRs or do anything that you might want. The repository is on GitHub, and I think Luciano is going to put a link up for it now, or at least hopefully. So yeah, feel free to reach out there with comments or PRs or anything else you want to know. Everything's well accepted. Like, we're just trying to learn Rust at the moment, so our solutions are, as you've just seen, not the cleanest or the most idiomatic, but if you have any better ideas, do let us know so we can learn, we can collaborate and make things better. So thank you once again for your suggestions and all the collaboration in the chat. It's really super useful. And we'll see you next week. Thank you very much. Bye.
Bye.